What's this? Seems where there are buttons and how does it work? Just nope. Maybe oh, welcome aboard the Sun Simulator. Please use joystick and enjoy making music. I would guess this is the joystick. So that's fun. Woo! Yay! So much fun.
Good morning guys, my name is Lorenzo.
And my name is Pietro.
We are two students from the Politecnico di Torino in Italy. We are attending a Master of Science in Computer Engineering, and we were asked to do a project in our computer architecture course on this development board. It mounts an NXP LPC 1768, and we were asked to use some peripherals in a creative way and try to invent something.
Okay, so about the development, we chose embedded C for the coding part. We built the project with Microvision, Kyle Microvision version 4, and to debug the project we use this little microlink to debugger, which is a device which allows us to interface with the board and examine what happened into the board. So, in this video we will try now to show all the functionalities, the flow of the code, of what we have implemented alongside with the code. So we can just explain you how we use these peripherals. But well, if you need help or any clarification, the code is on GitHub, the documentation is there, and feel free to contact us. Let's dig deeper into the world! Okay, so before jumping into the code, let's describe the functionalities of the board. Okay, the first thing to note is that the direction of the input of the joystick will determine the port which the board will connect to. So, for example, let's begin with down. Now, how you can see, the first after the joystick we're using the display. We have implemented a function to display text incrementally with a given delay that we can define. We will talk about this later. So now we use the speaker with PWM, pulse width modulation. It's just a principle in which changing the duty cycle for 1 and 0 we can give different frequencies, and so with digital outputs we can produce analog outputs like music with the musical notes. So for example, this is determined by the inputs of the joystick. So I will just, the trick is that there is a secret password that is coded like a sequence of joystick inputs, so like a sequence of musical notes. So what this happened when I wrong is just mistaken string, just to maintain the stealth of the board. Okay, let's reset the board. So now we'll try again, but this time with the correct sequence. So just wait for the text to be displayed. And now we shall try with the correct sequence that we know. So the board should communicate. So now there's this freaking display we have implemented. Okay, now
we have this menu in which we can grab an option. We printed some lines and we can select with the joystick, go up and down and pick one option. We have this menu once we connect to the Python server. Let's, for example, grab the first option. Alright, as you can see, we can display Darth Vader in ASCII, and let's pick the second one, for example. Here we can request TIE bombers. Here the board sends a packet to the laptop, and the laptop on the Python server tells us, based on the IP address that we have right now, the location in the world, more or less, where the TIE bombers should go. And the third option is a simple quiz to discover what kind of seat are you. So yeah, there are different questions. For example, the first one, you prefer breathing through a mask or through using a meat chunk? I'd say through a mask is better. So your favorite Darth Vader or Darth Vader? Let's say Darth Vader. Best pet, droid. Okay, Darth Vader. That's impossible. I'm Darth Vader. First choke over the wire. Okay, we implemented some simple functions in which the Python server will respond to the board and display the text. Alright, now I will explain the functions that we used in our project, the libraries, and we will go through the code. I will start with the joystick. Here there is the joystick init, which is a function which simply places this pin in input because we need to insert values from the joystick. Then I will show in func joystick we have this joystick get input, which is the function which actually collects the values from the joystick. I use one old value and one new value variables just to check if when the joystick changes its direction and to record the value. And I record the value every cycle, and if it changed, we enter in this function. We have this delay, and just to get just one value to the bounce, and then we return that specific value.
Okay, so let's talk about the speaker now. Our lib speaker, which is a low-level collection of functions, is just initialization function. We have took these things from the manual, which is just selection of direction and pin function. So this can be just take it as it is. About the func speaker, we have implemented two functions, tone and play music. Which tone is a high-level function, and possibly play music is even higher. So what it does with tone, which we have taken from the Arduino tone function, the idea is the same. So we initialize two timers, one for the duration, which will be responsible of handling the duration of the tone, and one for the frequency. So there will be this timer and this other timer. This timer is attached to an handler, which just set times elapsed 1 when the time has passed, when the duration time has passed, while the other timer just turns the speaker on and off, depending on the value of the actual speaker. So turning on and off the speaker, we can effectively sending a frequency squared wave and produce a sound with frequency. So this function is usable as it is. About play music, we thought that it was fun to implement a function that once we are able to play notes, why shouldn't we be able and give the possibility to play songs? So we have defined an encoding based on this array of musical notes number, which start from famous A4, which is 440 Hertz, and the encoding will be a string which is passed to play music, done like this. You can find an example. Oh, we should just go into channel, because the encoding is done like this. There's the index of the note in our musical notes array and the duration in milliseconds. This 24 note is just a pause. So for example, now we are playing na for half second, pause of 100 milliseconds, and na 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 na. Okay. So, respecting this encoding, this function can virtually play anything. And this is it about the speaker.
Alright, let's talk about the LCD screen. We used these three libraries, and there are really complete libraries. There are a lot of things. You can print a bar graph and charts, strings, and you can set color. There is really many functions. We needed to add another function, which is display text. Why? Because this function receives one line number and column number, then receives a string that you want to print and a color in which you want the string. And basically this function print texts, and then if it reaches the end of the line, it returns, and you can print all over the screen. If the screen is full, it starts printing in another I'd say page, a black one. And yeah, we needed to print all the text that you saw in the previous video.
Okay, so now for the fun part. The Ethernet was like a challenge to implement. We used these nice libraries from the Andreas Dannenberg. You can find all its information in the code. Now we won't describe in detail the emec.c, because you actually won't use this low-level function, but it's nice because it shows you how the Ethernet peripheral interacts with the DMA, direct memory access chip, and with the array descriptors on the chip. So Andreas has implemented a nice barebone TCP/IP stack with a simple API. There's everything. There's the initialization. We can passive open, which is listening for servers. Active open, which is opening a connection, and close. Then there's things like a release RX buffer and transmit TX buffer, which we will use to send and receive connections. And well, there's this nice do network stuff that is actually the TCP/IP stack implemented. So this function checks for the frames and checks for the TCP state machine, and it handles all the complexity of TCP connection. So we tested it and it's nice. It cannot handle more than one connection, so it's just a single connection, but it serves us well. So how did you use this function in detail will be explained when we talk about the channel and what we have done, explaining like all the flow of our project.
Okay, in the end I would talk about the Python server that we used on the laptop. We need to specify the port, and we set the correct password in here. We create a socket and we listen for incoming connections. Then, when the connection is accepted, we send back a code with a confirming code. Otherwise, we send another an error code. Then here, when we are connected, we have this loop. Here we have the handling of the functions, primarily the function for the IP address resolution, and then for the place in the word with an IP address. Then here we have the answers to the quiz, the different answers that we will send on the wire to the board in case the quiz is chosen.
So let's conclude our examination of the code, hovering and explaining all the function implemented. So there are just a lot of definition of strings that we will use, and encodings of the songs, and ASCII images, which we have used. This is for the metrics, but we'll get to that later. So at first we just initialize every peripheral. So system init, joystick init, speaker, ZDCD. We will initialize later the TCP low level init. So the first thing that we do is just waiting for the remote port, which is like this. Depending on what input we get on the joystick, we have a remote port to connect to. This we have done this because for the demonstration we needed to connect consequently to two different times. One for the wrong password, the other for the correct password. And reopening the same connection on the same port seemed to disturb, to annoy our operating system. So we just opened two different connections to two different ports depending on the first value. So after having entered the port, we just put ourselves in a loop when we try to construct the password with a value and tuning consequently accordingly. So this is why we insert the password with the tones. After that, we begin a low level init, TCP low level, which is required to use the TCP/IP stack. We assign the remote IP to which we will connect to. So this is the IP of the server, of the Python server, of the interface on which the Python server is running, and our local port. Then we will perform a TCP active open. This just doesn't get any parameter because we just set the remote IP and the local port, and this is just single connection, so it's okay. Then we just go in do network stuff to do the things that TCP/IP stack need to do, because we are not multi-threaded here. And channel is our function where we just check for the status of the socket, and if we have just initialize the channel, we send the password. How do send the password? We set this value with the size of the we check first that this is released. We save into this value the number of bytes of the password. We do a mem copy, so you can take this structure to send and to receive the data. So after that we switch into password sent. In password sent we wait for the answer, which could be OK code or wrong password. Well, we just go in a nice while one and happy lines which you have seen before in the video. In case the channel is connected, so the password is good, we just cast the menu handler. Menu handler is a function that takes list of strings, which is the menu, choice custom text, which is just what we want to show, and the num of entries. So this function is pretty straightforward. It's nothing to do with the peripherals. It's just a simple menu cast. Each function handles something, like in Praise the Empire, where we show Darth Vader, is just a sequence, so it's nothing more simple than that.